Hello guys, today's problem is maximum product of the splitted binary tree. In this what we have to do, we have given a binary tree, we have to split in two subtrees like this. So this will be one part, this will be one part. So we have to see if the sum of product is maximum or not. Means in which case the sum of the product is maximum, we have to return that maximum product. And there is a one note that you need to maximize the answer before taking the mod. So we have to maximum all the answers and compare it in maximum, then we have to take the mod and return, not directly mod. First we don't have to mod it and return it, otherwise your answer will be wrong. Okay, so here is one more example. Here we have done, so 1 2 3 3 4 6 into 15 90. Okay, now we will see what the question is. So to find maximum product, what we have to do, suppose we will divide it by this is part 1 2, this is part 1. What will be the easiest way to find the sum of part 1 or part 2? So I think part 2 sum is very easy to find, because what we will do, directly find we will return a solve function such that we can get whole, means this is the part of first part, is this second part, suppose. Okay, so nothing, left sum we will return, right sum we will ask solve to find. And what we will return here, see, if solve function is returning whole left sum, solve function is returning whole right sum. So what we have to find, just we will return in the recursion like root all val plus left sum plus right sum. It will give us whole. This recursion function in solve will give us whole. What is the left and right? If the root is null, we will return 0. One more case we will add. Okay, this recursive function will give us the part 2. But what about part 1 now? See, part 2 we can get by solve function. Okay, solve root of root a. Suppose this is a, so root a, and this is root parent. So you can see part 1 we can get by suppose solve of, we will do parent, root of parent. Okay, so just we have to remove this part 2 to get the sum of part 1. And what we have to maximize, we have to maximize part 1 into part 2. Okay, so for maximize part 1 into part 2, I should know what is this sum. Means, see, what we have the question, we can split it in at any part, here. Okay, for splitting here I should know this part sum. Okay, for if we are splitting here, I should know this part sum. If we are splitting here, I should know this part sum. Wait. If I am splitting here, I should know this part sum. If I am splitting here, I should know this part sum. Similarly, so what we have to do for each, for finding like this, so see, For each recursive function I will get O of n. But why this O of n? See, I will go inside this O of n by O of n. Then I will go inside this also. Okay, so it will take more. So we can't do this. So what we will do? We will memorize, means we will keep all the map inside map. We will do this one time recursive function and we will keep it inside the map. See, we will go this, suppose this is A, B, C, D, E, F, G. So what you will do, what the condition will be? Okay, firstly what we will do, okay. So we will ask to go to left. It will go to left. It will return A. Then it will go to right. It will return B. Here we will go. So here our answer will be written E plus A plus B. Here we got the left answer. Then he will call right recursive function. Here we will go right. Here it will return C. Here it will go. It will return D. It will return F plus C plus D and G, and here it will return G plus A, B, C, D is all. Okay, so what we'll do, we will map it according to each tree node. It is sum inside MP, so we don't have to repetitively call. So such that our this can be deducted to O of n into finding the sum equals to O of 1. So total complexity will become only O of n. But we can also, okay, but we have mapped all this sum inside this. We have mapped all the part 2 of the program inside this only. So why we will do this operation also? Why to go to recursive function again? We have part 2 all the things, so we will directly iterate the it.mp into in part 2 we can get by it.second. Okay, part 1 is, what is the part 1? It is the maximum sum of this. So it can be, means suppose total sum equals to map of root only, whichever the total sum will be. Okay, so our maximum product, so int product will be, what will be our product? Part 2 into the total sum which we got by map of root. Suppose this is the root, we will directly ask mp of root, what is the sum? So it will give G plus A plus ABC plus GF. Okay, so into total sum minus part 2. So just we have to maximize this. We will ask maximize for each level. Here we will see the code. See if the root is need. See here what I have done. I have written the map for storing all the tree node sum, and modulus is 10 to the power e9 plus 7. So here what I am doing is that root equals to null, so I will return 0, because if it will go here it should return 0. It is also null, it should return 0. Okay, I will ask ref child what is the solve function for you, right child what is the sum you are returning. Okay, so what will be our current sum of this node? It will be root dot value plus what is the left child sums, what is the right child sums. Okay, means if this is our conditions, so our root value plus left child sums plus right child sums will be our current root value, which are we will return as that. So we will store it inside the map of root and return the root. This will give us whole recursive function will give us mapping whole tree nodes. Okay. So we have called the first the root sums. We will get the total sum by the MP of roots. What is the maximum product for long? We are using long product equals 0. Part 2 is int id dot second. What will be our long product will be value into total sum minus part 2. Maximum product is equals to max of that. We will do mod at last and we will return the solutions. So you can see what the solution is. Thank you.